So, in the last classes, we discussed about multi-layered perceptron. Now, this was one basic structure of a neural network. We are going to talk about different neural networks in this whole course. So, now that we know that MLP was one part of a neural network, what are the different parts? We know how MLP is designed, we know how to code this, and we know how to code this in fact two different frameworks. We have TensorFlow 1 and then we have Keras. So now that we have completed the whole thing about this multi-layered perceptron, let us shift into the second type of neural network. So the name is CNN, Convolution Neural Networks. So CNNs, we are going to discuss about CNNs now, convolution neural networks. So what exactly are CNNs? Where are they used? Why should we use CNNs? Well, we will understand everything in a course of few other videos, but right now what I should tell you about is CNN are basically used for any image related tasks. So if you remember, the one problem with multi-layered perceptrons that we had was we had to flatten out an image so that it could fit into a multi-layered perceptron. But what if we have to use both the dimensions? In that case, we use convolution neural networks. So anything that is related to image, so you can say from classification of image or object detection or anything as such, we use CNNs. So CNNs are the basics there. Okay, so now let me show you. This here is a multi-layered perceptron, right? And this here is a structure of a convolution neural networks. Now I don't expect you to understand the whole thing right away obviously, but let me just give you a brief example. What was happening was we had this image, right? We had this image, this MNIST image, and we were flattening it out and then passing it as input, right, in a multi-layered perceptron. What in CNN happens is, this is an image, so you have this length here, you have this width here, and this thickness here, this part, this is basically the different channels. So you know every image has this RGB channel, right? Red, green, blue. In MNIST what was happening was, it was black and white images, so the channel was 1 in that case. But here we will be having 3 different channels, red, green and blue. So that is why you have this thickness here, you have the length and you have the breadth. So what happens in CNN is, it actually takes this into consideration, that you have a length and a breadth, and then it creates different things and you finally get the output. So we will go into the details, everything, but this is the difference between the whole structure thing. Okay, but before we start with convolution, what convolution means and everything, let me bring you to this thing known as edge detection. So we will start with edge detection and then one by one we will go, and I'll tell you and make you understand actually why I started with edge detection as such. So edge detection basically is, you have an image and it detects the edges here. I'll show you how it does that. Once you get that understood, it will be very easy to make everything else understand. 3, 4, 5 and 6, okay? 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. So let's say we have all these 0 here, that means these are the black pixels. So you have an image, okay? So you have an image, you have all zeros here, and here you have 255s. So these are all white. So if you actually try to understand what this image means is, you will understand. So all this is 255, 255. So what this basically means is, so we have this. So what this actually means is, if you will understand, we have this whole thing as black here and this whole thing as white here, right? Okay, let me just change the colors. So let's suppose you have this here, this structure here, this thing here is black. right? And then here, let's just suppose I'm not giving it white, let's just suppose it's blue or something. So this blue basically means it's white here. I'm just giving it a color to make you understand. So this here, this one, this is an edge, right? So this is how we are representing it in the form of numbers, and what our task is to basically identify this edge. So what we will do is we will convolve this. So this is the sign for convolution, right? So we will convolve this with an edge detector. So what does an edge detector look like? So we have +1, +2, +1. Then we have 0, 0, 0, -1, -2 and -1. Right? So this is our edge detector. This is also known as a Sobel edge detector. This is used to detect horizontal lines. So it is known as a horizontal Sobel edge detector. Right? So what will happen is, the first thing is that this thing will be, this whole thing will be placed here firstly. So we place this here. So what does this come to now? Here +1, +2, +1, 0, 0, 0, -1, -2, -1. Now what will happen is we will multiply each of this value that was already there in the image with the value that we got from this after placing this whole kernel or this detector here. So what does this come to? So we have 0, 1, 0, then 0, then again a 0, 0, 0, 0, everything will be 0, right? So if we have this output here, so our output will be of this shape. Now why this happens also I'll explain it. So the first thing that will happen is, after multiplying this whole thing with the zeros, once it has been multiplied, the whole thing will get added. So like we were doing in MLPs also, we are multiplying the weights with the inputs, right? And then we were adding the bias. So in this case also we will be multiplying all the weights. These can be thought of as weights, right? So these weights with the inputs, and we'll add the whole thing. So what does this end up to? 0. So the first value here will be 0. Now let us go into the second value. Here, now we will place this here. We will move it one step towards the right and place it here. So what do we have now? +1, +2, +1, 0, 0, 0, then again -1, -2, -1. The whole thing, since this is 0, this will again come down to 0. What will happen? We will multiply each value after placing it here with the actual value that was present. So what will we be having? We're having +1 with 0, +2 with 0, +1 with 0, and the whole thing comes to 0. Once we do that, we will add the values, and here again we get a 0. Now what we will do is, we will push this one step downwards now. So it was in this row, we'll just shift it one step here. So now our detector is in this place. So what basically we are doing is, we are moving this detector horizontally by one step and vertically by one step, right? So now we will be multiplying this. Again this row and this row will come as 0 because the whole thing is 0. So we have 0 plus 0 plus 0, then again +0 plus 0 plus 0. Now for the final layer we have here -1, here -2, and here -1, right? So what does this come down to? So we have -255, then -2 into -255 is again what? -510 and -255 again. So we add this. What value does this come down to? 1020. So we have -1020 here. Since we have moved this one step downwards, so our output will also be one step downwards here. So in the same way, we'll have 0 here and 0 here, and since it has moved a step downwards, and this area, if you will see, is the same as this one here. right? This part, this one right here, and this one are the same things, right? So the value will again come to minus 1020 here. In the same way, one shift here will also give you minus 1020 and minus 1020, right? So this has happened. So it has shifted here, this has happened. Now let us shift it one step again downwards. So we have this here. So again this will give zeros because the whole entry is zeros. This here will be again zeros because we are multiplying it with zeros. And the final one here will again come down to minus 1020. In the same way, we'll have minus 1020 here, minus 1020 here, and minus 1020 here. And then finally we'll come down to this final one. Okay, I don't think we have any more colors, but yeah, we have this one. Just try and understand. So her whole thing here is 255. So first of all, let's go for the middle row here. We are multiplying this with this. Since all of this is 0, this comes down to 0. Alright. This is basic calculation. I mean, you can sit and do it yourself if you think this has become a way more clumsy. So you have then plus 1, plus 2 and plus 1 multiplied with this 255. So you get plus 1020. And you have minus multiplied with this whole thing. So you get minus 1020. So this comes down to 0. So in the same way, we'll have 0 here, here, here and here. So what you can do is, you can take this example and you can convolve it with an horizontal edge detector and you can see what values you are getting. You can try this out one by one and then you can understand the whole thing, right? But the whole thing, the final product that we are getting is something like this. We have 0, 0, 0, 0, 4 zeros. We have minus 1020, minus 1020, 020, minus 1020. Again we have the same thing. So what we have done is, we have convolved here an image which has one edge with an horizontal edge detector. Why did we use a horizontal edge detector? Because it has one horizontal edge. If you will see here, this was our image. It has one horizontal edge. That is why our horizontal edge detector. So this is our final output. These are the different pixels that we will be getting. What we can do is, let us normalize this. What does normalization mean? Normalization means is, the value should lie between 0 to 1. So after normalization, the value that you will get is, you can do that on your own, but I am just saying the value that you are going to get is so this will come out to be 1, 1, 1, 1. You'll have 0, 0 here. And then 1, 1, 1, 1. So now if you see, this has been the value after you have converted. So what does this look like? Let us see this in the form of an image. So we have ones here, so that means it is a white thing. And we have two lines of black, 0. So we have this here. So we are getting this output, right? This is our output. So if we represent the white, let's suppose with blue color. So we have blue here and blue here. And we have one black line here. So what this has done is, it has identified our edge that was here. How was our edge? Our edge was something like this, right? We had whole white here. Or was it black? Okay, we had whole black here. Okay, let me. So we had black here and we had white here. This was our edge. Now this edge has been detected in the form of a black line here. So what this whole edge detection is basically detecting all the edges in the image, right? The sharper the contrast between the values, like here what we had 0 and 255 exactly. So the contrast here was, these whole things were 0 and this thing was 255. So the more the contrast, the higher this black is going to be, the higher this value is going to be, and the sharper this line is going to be. That means the more easily you are able to detect the edges. So that is the whole point of edge detection. So let me just get you familiar with a few concepts here. So we have an image which is what it is, basically just a matrix of numbers which represent colors, right? We have an image here. We will be convolving it. This sign is known as convolution or convolution sign with an edge detector. Edge detector. How does our edge detector look like? We have +1, +2, +1. This is followed by 0, 0, 0, and then we have 1, -1, -2, and -1. This is what our edge detector looks like. This is known as a Sobel horizontal edge detector. So we have our edge detector here. We will be convoluting it with the image. And this whole thing, how does the convolution work? Let's go back again once more. So we have our image here, and we have this edge detector. One by one we'll place the edge detector once here, and we'll get the first value here in this square. Then we will place our edge detector once to the right, and we will get the value here. Then we will place it one step downwards, and we get our value here. Then again this will be shifted this side. You will get the value for this part. You can shift this again to the right. You can get the value here, and then one more time, and you can get the value for here, right? And in the same way you can do this here again, downwards and then downwards, and you'll get the two values here. You just have to keep shifting this edge detector, and then finally shift it one more time downwards, 3, 4, and then you get the final values for here, right? So this is how our edge detector works. Now the shape of the in which this output will come, like here what I did is, see, you had this 6 cross 6 matrix here, and our edge detector was 3 cross 3, and I finally came here, and this output comes out to be 4 cross 4. How this is coming out, this answers and everything also I'll explain, but for now let us just keep it in this way. So the other way in which you can say is, this edge detector, this box that we say, this can also be known as a kernel. So a kernel is basically used to find an edge detector. So one type of a kernel is an edge detector, and finding out edges in a picture, finding edges from a picture is one type of convolution, and it gives us one output. So this edges of a picture can also be known as one, let's say, a feature of a picture. Like I can count the number of edges and everything, so it can be a feature of a picture, right? So what we can say in short is, an edge detector helps us find a feature of a picture, or kernels are used to find features of picture or an image. So in short, how are these kernels used? With the help of convolution. So this is basically how convolution works. Now I'll go into the details and depths way more afterwards, but in short what you can understand right now is about edge detection, right? So this is it for now. Keep learning and have a nice day.